Metal heat treatment is one of the important processes in machinery manufacturing. Compared with other processing technologies, the purpose of heat treatment is to endow or improve the process performance and performance of the workpiece by changing the microstructure inside the workpiece or changing the chemical composition of the workpiece surface. Among them, heating temperature, holding time and cooling rate are called the three major elements of heat treatment. What is the principle of heat treatment and how do the three major elements work? The first is heating, which is the first process of heat treatment. In most cases, heat treatment needs to be heated to a partial or austenitic structure first. So the heating process of steel during heat treatment is the austenitization process. What temperature should steel be heated to? In actual life and production, about 60 to 70% of the parts in machine tool manufacturing are subject to heat treatment. In the automobile and tractor manufacturing industry, the parts that need heat treatment are as high as 70 to 80%. In the die rolling bearing, 10% of the parts need to be heat treated. In short, important parts need proper heat treatment before they can be used. So what temperature should the heat treatment be heated to? The theoretical condition is that when the temperature is higher than 727 degrees Celsius, you can get the Austrian entity. From the iron-carbon alloy phase diagram, it can be seen that the line A1, the line A3 and the line ACM are the critical points for the structural transformation of the steel in the equilibrium state. However, in actual heat treatment, both the heating rate and the cooling rate are faster. The phase transition temperature tends to be higher when heating and lower when cooling. The faster the heating or cooling, the more severe this phenomenon is. Usually, we mark the actual critical temperature during heating with the letter C, such as AC1, AC3, ACCM, and mark the actual critical temperature during cooling with the letter R, such as AR1, AR3, ARCM, etc. From this point, we can conclude that when the steel is heat treated, the lowest temperature of austenitization is AC1. When it is heated to above the AC1 temperature, the original structure of the steel will be transformed into austenite. For hypoeutectoid steel and hypereutectoid steel, it needs to be heated above the lines AC3 and ACCM. In this way, the pro-eutectoid phase can be fully transformed or dissolved to obtain a monolithic austenite structure. To be fully austenitized. When the heating is over, keep warm. The purpose of heat preservation is to make the workpiece heated evenly, the structure transformation is fully carried out, and the most important thing is to obtain uniform austenite, so that the ideal structure and properties can be obtained after cooling. Here, students must pay attention to the size of austenite grains. In engineering, it is often hoped to obtain fine and uniform austenite grains. Then when heating and heat preservation, we should pay attention to, first of all, in the case of ensuring uniform austenite composition, choose the lowest austenitizing temperature as possible. Second, quickly heat to a higher temperature. Austenite is formed after a short holding time, before it has time to grow and then cool, so that fine grains can be obtained. Cooling is the final process of heat treatment and the most important tool for heat treatment, because it determines the structure and properties of steel after heat treatment. In heat treatment production, there are two commonly used methods: isothermal cooling and continuous cooling. Now let's take a closer look. Heat treatment refers to the process of heating, holding and cooling metals in a solid state in an appropriate manner to obtain the expected structure and properties. It can be seen that cooling is the last process of heat treatment. and it is also the most important process of heat treatment. Why do we say that? Practice and experience has proved that after heating the steel with the same chemical composition to a uniform austenite state, if different cooling methods and cooling rates are used, different structures and different mechanical properties will be obtained. In heat treatment production, there are two commonly used cooling methods: isothermal cooling and continuous cooling. What is isothermal cooling? Isothermal cooling is to rapidly cool the heated austenitized steel to a temperature below the critical temperature AR1 for heat preservation. Perform isothermal transformation at this temperature, and then cool to room temperature, such as isothermal annealing, isothermal quenching, etc. Continuous cooling is to continuously cool the steel heated to the austenitic state to room temperature at different cooling rates, such as water cooling, air cooling, furnace cooling, etc. From the schematic diagrams of these two heat treatment cooling methods, we can see that the main difference between them is whether the steel is kept warm and undergoes isothermal transformation when it is cooled below the AR1 line. Then, according to the different heating and cooling methods and the different characteristics of tissue properties, what are the types of heat treatment? It is divided into overall heat treatment, surface heat treatment, chemical heat treatment, and other heat treatment. Our course is mainly to explain the overall heat treatment, which includes annealing, normalizing, quenching and tempering, which is what we commonly call four fires. Annealing is a heat treatment process in which the steel is heated to an appropriate temperature above or below AC1, held for a certain period of time, and then slowly cooled. The characteristic of annealing is slow cooling, generally using furnace cooling and sand burial cooling. Normalizing is the heat treatment of heating the steel to AC3 or ACCM above 30 to 50, holding it for an appropriate time, and uniformly cooling it in the free circulating air, which is called normalizing. The purpose of normalizing is to normalize the structure of the steel. First, for low and medium carbon steel, the purpose is the same as that of annealing. Second, for hypereutectoid steel, it is used to eliminate the network Fe3C and prepare the structure for spheroidizing annealing. Third, final heat treatment of common parts. Normalizing is essentially a special case of annealing, with the main difference being the cooling rate. Normalizing has a large cooling rate and a large degree of supercooling, and the resulting perlite structure is large in number and relatively small, so the strength and hardness are also high. Quenching. Heat the steel to an appropriate temperature above AC3 or AC1, and after holding it for a certain period of time, rapidly cool it at a speed greater than Vc to transform austenite into martensite or lower bainite. The heat treatment process is called quenching. Commonly used quenching media are water, oil, water-soluble salts, and alkalis. The types of quenching are: first, single liquid quenching; second, double liquid quenching; third, martensite graded quenching; fourth, bainite isothermal quenching. Tempering is a heat treatment process in which the quenched workpiece is reheated to a temperature below the AC1 temperature, and then cooled to room temperature after heat preservation. Purpose of tempering: first, to reduce or eliminate internal stress to prevent cracking and deformation of the workpiece. Second, to change the structure after quenching from unstable to stable to stabilize the size of the workpiece. Third, to adjust the performance of the workpiece to meet the use of the workpiece require. Tempering is generally a heat treatment process immediately after quenching. It should be noted that tempering is meaningless for unquenched steel. It is good. Thanks for watching. Bye.